In this video, we're going to talk about wiring up the reflectance sensor array and then how to write the code to go ahead and read it. So under this lecture 9b, you have a link that explains how to mount it. So um, using the 3/4 inch standoff. And so what we're going to talk about now is how to wire it up. So you have the port assignments here. And you can see that the analog to digital pins, you can, for the line tractor, we're suggesting that you use either 20, 21, or 22. You can just use 2 of them. If you want to, you can use all 3 of them. But you may just want to use 2. So if we look at the pinout here, you can see on this column right here, there's pin 22. I'm going to use pin 22 and pin 20. And then I'm also going to power the reflectance array. There's 5 volts is right here. And then on this column, any of these pins will be ground. So if I switch to the camera, right, so in other words, I've got my black wire here is just going to ground. The red wire is going up to this 5 volt pin. Right, let me just again show you where that is. That's this pin right here. So that pin is 5 volt. I have a red wire going to the 5 volt, a black wire going to this is to the ground. And then I have this blue wire, and that's connected to 9. So that's going to be on the right side. And I have that coming over, it's a little bit hard to see, to this pin over here, which is this one right here, 22. So the blue wire is going to this pin, and then I have a yellow wire which is going to go to this pin, right? The yellow wire is going to 3, so that's going to be the left side. So anyway, so those are the 4 wires that I have wired up to the 32U4 going from the reflectance sensor array. Okay. All right, so now if we go to Platform IO, so I'm calling this my first reflectance project, and I already have, I usually just copy the folder from a previous project and then just rename it, and then that way this platform.ini platformio.ini is already set up. And then in the main.cpp, I've included Romi 32U4.h and then the chassis.h, even though right now, right this minute, I'm not using the chassis object. But and then, as I said, the left wire was going to, or the wire on the left side, I was going to put that to pin 20, and the wire on the right was going to pin 22. It did a serial dot begin so that I can print to the screen. And again, I'm not using the chassis just yet. And okay, and then I just start out with hello world, wait 2 seconds, and then I just run this loop for a little while. So I do a serial print, the left reflectance, print in a space, and then do, again, using the analog read, grab the right reflectance and delay 100 milliseconds and keep doing that. So remember that on the 32U4, the A to D analog to digital converters, they're gonna convert a voltage between 0 volts and 5 volts. In return, it's a 10-bit converter, 10-bit. So that means that from 0 to 5 volts, it's going to give you return a number between 0 and 1023, right? 2 to the 10 is 1024. So the possible numbers are go from 0 to 1023. So if it's 5 volts, it would be reading 1023. If it's 0 volts, it's going to read 0. okay? And yeah, this other part isn't anything I'm using right now. So anyways, I'm going to go ahead and plug this in and get this going. Okay, and it's going to take a minute here and make sure, click on this plug, make sure it's showing me the screen. All right, so this should be running. I'm not sure what's going on here. Ah, there we go. Okay, so let's close that. All right, so let me move this and I'll get the camera going again. All right, so you can see that it's returning values right now. So I have a piece of 3/4 inch black tape, and if I move it to the left, then the right side, you can see the right side values go way up. It's it's by quite a bit, right? So it's pretty sensitive. So, and then, yeah, periodically it says hello world and starts over again. And then if I move it back so it's centered, and then keep moving it, and now the left side is going up, right? That going up pretty high. Or if I move it back this way, then the right side goes up, right, pretty close to 900 there. And when it's on the center, let's see if I get this, so it's pretty close to being centered. So anyways, what you can do then is just say your error is equal to the difference between the left and the right, or the right and the left. You can figure out which one you want to use, and then use the method for the chassis to follow the line. And of course, the nice thing about here is you can use a proportionality constant times that difference to adjust it so that it responds, optimally, following a line. And then, of course, if you run into the crossing line, then they're both going to go high. Like if I move this so that the right one is over, so if I hit a crossing line, they'll both go high. And if you can just be checking as you go to see if that both the left side and the right side are above some threshold, then you know you've reached the crossing line. And then the same way, of course, if you're trying to do a turn, so right now, if I do a turn, they're both low, and I keep turning, and I'm trying to figure out, I want to keep turning until I start to pick up the line. As soon as if I'm turning to the left, as soon as the left one goes high, then I know I've reached the line, and I can start line following again. And okay, there we go. Okay.